Yeah, I got to tell you, that LISA award was just, I'm so proud of that. That was so wonderful. You know, yeah, anyway, so I know that I came from the Unix community, and I know that you guys just have great taste. So to be recognized by the Unix community was wonderful. Anyway, so I'm going to talk to you about desired state configuration and Windows. In fact, that's not quite true. I'm going to talk to you about desired state configuration and the cloud. Okay, so first, let's go through the agenda, right? I want to get desired state configuration in focus. So I'm going to talk about why we're doing desired state configuration. I'm going to talk about what desired state configuration is, and then why Microsoft has chosen to take PowerShell desired state configuration and make it available on Linux. Not obvious why that's the case. So those are the three things I want to achieve today. So first, why desired state configuration? A lot of people ask us this question, but they're really asking a slightly different question. What they're really asking is, why not? Why not Salt? Why not Chef? Why not Ansible? Why not Puppet? Why not CF Engine, Guardrail, Brewmaster? There's a lot of great Unix tools out there. Why are you reinventing the wheel? Why not just pick one of these and go with it? Okay? And I assert that that's actually the wrong question. Why PowerShell DSC is the wrong question. The right question is why PowerShell? Why did you go invent PowerShell? And that's the key thing. Why not just use Bash, K-Shell, whatever? We got all these great Unix utilities and we have these great Unix shells. Why did you go reinvent the wheel with PowerShell? That's really the question. So first, I'd start with a little history. So first, both myself and my team, most of our team, have deep Unix backgrounds, right? So we love Unix. We just do. We love it. And I think if anyone's used PowerShell can do that. In fact, my all-time favorite blog was someone wrote in the early days of PowerShell. They said, oh my God, it looks like Microsoft hired a bunch of Linux guys or Unix guys and then paid no attention to what they were doing. So I like that one. Anyway, so we got that. I joined in 1999 and immediately started pushing for, hey, we need CLIs, we need shells, we need command line interfaces, we need an admin administration model, admin automation model. And that was very, very difficult. Encountered some cultural pushback. In fact, one of the senior executives took me aside and said, Jeffrey, exactly what part of effing Windows confuses you? So that was a day. And then at some point I had another one say, hey, we know admins don't want command line interfaces. They want GUIs. And I said, oh, what did you do before you came to Microsoft? I said, well, I came here from college. I said, yeah, I knew that. You've never done anything. Anyway, so there's some deep, deep, deep cultural pushback to this. Yeah, there you go. But finally I prevailed. I remember the meeting like it was yesterday. I'm sitting there and I was making my case passionately for why we needed command line interfaces, why we need shells, etc. And finally the VP said, yes, we've got to do this. We've got to commit ourselves to this. And I can't tell you, I just felt so wonderful, like, finally, I'm going to get Windows into the real world. And then she said, which 10? And I said, what do you mean, which 10? She said, well, which 10 command lines should we do? I said, I don't understand what you're talking about. She said, well, it's going to take us a long time, so let's focus, let's figure out which 10 we're going to do. It's like, oh my God, this is going to take a long time. Okay, so eventually I pushed, and came that close to getting services for Unix, which is all the shells and all the Unix utilities available or shipped in Windows. But the last minute, some concerns around IP, that got squashed, but we made it available free as a download. So indeed, services for Unix, all the shells, all the Unix utilities running on Windows, happy days, right? Glory, glory, glory. Problem solved? Absolutely not. This didn't help at all. Didn't help anything. And the heart of it was, but although it helped educate me, the heart of it was this issue around a document versus an API-oriented operating system. Okay, so let's drill into that a little bit. Unix is a document-oriented operating system, right? Everything's a file. Most everything's a file. So if you can edit a file and restart a process, you can manage most everything in Windows or everything in Unix, okay? All the management tools are glorified abstractions on top of editing files and restarting process. By the way, there's glorious semantics to some of this stuff, right? If you think about it, sometimes you step back, you take these things for granted. When I open up a file and I'm editing it, it gives me transactional semantics, right? If I make a bunch of changes and none of them take effect until I hit save, and when I hit save, all of them take effect. That's wonderful, glorious stuff. So this is a fantastic approach. You have some issues around schema, like do you know how to edit that file? Data validation, parsing, et cetera. But some great things to this. So in this model, awk, grep, sed, these are really management tools. You can do a lot of management with these tools. However, Windows is an API-oriented operating system, right? All these things are hidden behind APIs. And there's great benefits to that as well, but they're fundamentally different, okay? And so in this case, awk didn't work against WMI. I got a ton of great stuff in WMI. You can't get at any of it from awk. grep didn't work against Active Directory. Sed didn't work against the registry. Basically, none of these tools really helped, okay? So that's the heart of the problem. So the lessons I learned from this are these Unix-style documentation manipulation tools, they don't really work on Windows. And they just don't work. Now, I will point out that IIS provides false hope, right? It turns out that we have one workload. It's a very important workload, but one workload that works with documents, and that's IIS. So a lot of tools will come along, Unix tools will come along, and they'll get on Windows and say, look, I can manage IIS. I'm a Windows management tool. And then they say, by the way, how do I add something to Active Directory? Where's the document for that? And where's the document I can edit for WMI? And it's like, yeah, goes nowhere. So lots of people sort of land on this beachhead and then stall, right? So this is the reason why we needed to invent PowerShell. And if you read Bruce Payette's book, Bruce Payette was a developer lead on the language. He wrote a fantastic book, PowerShell in Action, and he goes through the struggle we went through and how we thought about things and how we made our decisions. And you'll see we tried to invent as little as possible. So we actually started off with the POSIX definition of shell semantics, added a bunch of Perl, and then invented where needed. I wrote the Monad Manifesto, which really declared what it was we were trying to do, what problem we were trying to solve, the approach we were taking, et cetera. And basically what we were trying to do is deconstruct the Unix model and then reinterpret it in the context of an API-oriented world. I'll talk a bit more about that. But basically this idea is that pipelines of text are replaced with pipelines of objects. And prayer-based parsing is eliminated. You know that thing where you run a file and then you say, okay, now I'm going to cut off 3 lines. Is it 3 or 4? I'm going to go over 27. Is it 27 or 26? Is that a tab? Oh, shit. Anyway, just pray. You write your little regular expression and you pray that it's right. And oddly enough, it somehow sort of works often. Anyway, so let me go back. I'll give you the genesis of PowerShell. As I did this deep reinterpretation of the Unix model, I said to myself, well, what's the heart of the Unix compositional model, right? It's A pipe to B, pipe to C, right? You do something, you pipe it to something else, you pipe it to something else. It's all composition. And every now and again, I got to tell you, it's really worth stopping and just asking a bunch of dumb questions and then exploring it. So I asked the dumb question, why do people do this? And I thought about that a while. I said, oh, well, they do this because A doesn't do what you want it to do. If it was, you just type A. So then I asked, well, why doesn't A do what you want it to do? And that's where it becomes interesting. Now, there's 2 answers. There's the traditional Unix answer, and that says, hey, that's the model. We can never know a priori what the scenarios are. So instead, we build toolkits of small general-purpose tools that do a really good job at a particular thing, and then we compose them together. And then, as a new thing comes up, we just compose them in different ways. It's incredibly powerful, like one of the most powerful things the industry's ever seen. Just wonderful. But there's another answer. And the other answer is, well, A doesn't do what you want it to do because it tightly binds 3 separate steps into one step. A, I assert, gets a set of objects, it processes those objects, and it outputs those objects, typically as text. So here, when we say A doesn't do what we want it to do, what we're really saying is, I didn't get the objects I want, or I didn't process the objects I wanted, or I didn't output them the way I wanted. So seen in that light, piping to B and C is really the process of taking the output, the text, and trying to reverse engineer your way back to the original objects so you can do one of these steps differently. Okay? With PowerShell, I just said the pipeline belongs there. Okay? So you pipeline the objects, you work against the objects directly, and you only output text when you want to output text. And that's the heart of PowerShell. And this is how I'm able to take the Unix compositional model and apply it to Windows, an API-oriented system. Because many of the objects, the APIs that I'm going to call, are going to generate the objects. So I get the objects from those APIs, I process them as objects. You'll see there's a lot of trick to do that. And then I only output text when I want to. So that's the heart, conceptual heart of PowerShell. So that was back to the question, why did you do PowerShell anyway? Now let's talk about why desired state configuration. So again, I mentioned to you that a lot of these Unix tools just hit a wall when it comes to Windows. In fact, I was talking to the CEO of one of these companies, and he said, yeah, we're just going great guns, and then we hit a wall when it comes to Windows. You know, how do I do this and this and this? I said, yeah, my friend, that's the problem. It's a task. So we needed a tool that worked against an API-oriented operating system. So what is desired state configuration? Well, I like to think of it this way. You all remember this guy, right? Jean-Luc Picard. This guy is awesome, right? He just sits there and he says, here, make it so. Here's the way I want it to be. And then this poor guy comes along and he's got to do all the hard work. You know, just, yes, sir. And he goes and makes it so and only talks to the guy when he can't make it so, okay? But it's a little more complicated than that, right? If you'll recall, Star Trek had quite a few captains. And so one captain will say he wants to make it so, this guy's got to do it. The other captain might want to do it a different way, and he's still got to do it. And a third captain might want to do it a different way. And still, the number one's got to do the task, even though it might be different. And so this is what I'm really kind of motivating here, is the need for a platform. Okay, a platform that allows multiple people to be able to say, hey, I've got a different vision of the way the world ought to be, but I want you to make it so anyway. So that is what desired state configuration is, PowerShell desired state configuration. Desired state configuration is a tool-agnostic, distributed, heterogeneous configuration management platform. Okay, so platform. Build multiple tools on top of this distributed heterogeneous platform. So what does it do? It ensures that all the components of your data center have the correct configuration. It supports continuous deployment. It's going to prevent configuration drift, right? It'll detect drift and then either correct it or notify you about it, report against it. And it enables this declarative, autonomous, idempotent deployment configuration according to using a standards-based model. So when we did this, indeed, we had to do it. We did it for Windows. We needed a model for Windows. But when we did it, instead of it being Windows-specific, instead, we decided to put industry standards at the heart of the design so it could be used by anyone on anything. And the most important is that it enables a broad ecosystem of configuration management tools. Okay? And that's critical for our platform, right? I just think about a customer who says, oh, I'd like to do configuration management on Windows. And he comes to you and says, oh, you got a great product. You know how to manage Exchange. And that's great, except, oh, you don't manage SQL. And, well, you can manage SQL, but you can't manage Exchange. And, well, which product do I buy? And it just seems bad for everyone, customers, vendors, me, to say that configuration management products vary based upon how they can manage Windows. That is to say, whether or not they can manage Windows. I want to build a world where they can all manage Windows uniformly. So just take that conversation off the table. Now, oh, how do you do management? Are you more graphical? Are you more focused in on reporting? Do you do reasoning? Do you do this? Do you do that? That's a great conversation to have. But it hurts a platform to be able to say, these guys can do this management and these guys can't. And that's why we're taking the platform play here. So why, if you think about the traditional model, right, traditional scripts, there's a ton of stuff going on that you have to do, right? Dependency resolution, blah, blah, blah. This gets all transformed into desired state configuration, where you first specify the configuration. How do you want the world to be? Okay, your intent. Then at the bottom, we have these resources. These resources are built by the people who generate the this resource themselves, right? So we work with the Exchange team, we work with the SQL team. They're going to write those resources in a well-defined way. And then we've got this desired state configuration engine. That engine does things like dependency analysis and resolution, logging, reboot consolidation, all that great deterministic automation, okay? Okay. So here is the architectural model, right? The big animal picture for PowerShell desired state configuration. At the heart of it all is a document, a configuration MOF. A MOF is a standards-based document, DMTF standard, that describes how a managed resource should look like. It looks like JSON, right? A little bit funky, but basically JSON. Excuse me. You then take that document and you give it to our Make It So agent. That Make It So agent has a local configuration store. It has a processor, a parser, and a dispatcher, and then it calls a number of these imperative providers. These imperative providers can be written in C or C++ or in PowerShell itself. And then the question is, well, how did I get that document? And the answer is any way you want. Any way you want. So you can use any tool you want. PowerShell version 1, version 2, version 3, they can generate ASCII text documents. Perl can generate ASCII text documents. Notepad, VI, they can all generate ASCII text documents. Do anything you want. However, PowerShell version 3, 4, and PowerShell version 5 have specific language extensions that make it easier to generate these sets of documents. But I want to stress, this is a standards-based document. You can generate this any way you want. Now, PowerShell version 4 and 5 add declarative syntax extensions to the language. And the point is that we can go, being standards-based, we can go find out what the schema of the objects are. And what that means is when I'm doing editing, I have IntelliSense, and I can do schema validation. So I can, when you're writing the document, I can say, here are the properties that are available to you. Hey, you've got a property that's got out of range or has the wrong data type. And then I can do validation, render these documents and take a look at the objects across multiple things. And do model confirmation, reasoning against the model. Oh, sorry. Now this is all a push model. Okay? So you got a set of tools, they generate the document, and then you push it to the node. So how does this actually work? In the case of PowerShell, what we do is we have this configuration script, you run it, it compiles into this MOF document, right? That's that ASCII text document. This is our authoring stage. And then you push it to the node, and here again, you use standards-based management. There's a WSMan protocol, standard DMTF protocol. You push it to the node, and then there, the agent then calls a bunch of these DSC resources. So pretty simple model. By the way, there was the other thing I told the team. I said, look, you guys are great engineers. Don't show off with this stuff, right? The DevOps guys have a wonderful phrase. They say, the problem is that scale times complexity exceeds skill. So when you're trying to do things at scale, if you have things that are complex, there's too many things that can go wrong. And when things do go wrong, they will go wrong, there's too many things to consider. What about this, or what about that, what about that? So for scale, what you want to have is a very, very simple model. And so that's what we have here, a very, very simple model. So I mentioned to you that that was a push model. We also have a pull model. The pull model, basically, you can configure this agent to then go and pull this configuration document from an endpoint. And here what we chose was a REST API. So there's a well-defined REST API that this guy, you can configure it to go talk to, and it will then pull down the configuration scripts, it'll report its status, etc. That's a very efficient REST API that we're using there. So it works in both a push and a pull mode. Again, as we talked to the configuration management tool vendors, some of them wanted to do it one way, some of them wanted to do it the other, so we're going to support both. So the continuous delivery support, basically the model has, now this I'm talking about in the context of PowerShell authoring. PowerShell authoring has explicit separation between the structural elements of a configuration and the environmental elements of a configuration. So for instance, you might say, hey, I'm going to have a front end, a back end, mid-tier and a back end, and here are the components that I'm going to have on it, and here's how they get connected. Now, for test, for development, I want one of each. For test, I want to have 5 front ends, 2 mid-tiers, 1 back end. For development, I want to have larger number, larger number, larger number. Here are the names, here are the IP addresses, etc. Those environments are completely separate from the structural information. So what that means is you're using exactly the same code in all of your environments. By the way, we formally model disaster recovery as well. So we think dev, test, production, disaster recovery. Because it turns out there's some very interesting, being in production and going over to disaster recovery and back, there's some very interesting configuration management steps involved in making that actually work. And we've thought through that. Anyway, so we directly support that to maximize the code and code reuse, and therefore maximize the probability that things are going to be the same across the environments. So let's do a demo here. I'll give you an evolution of a script. Okay, so this shows you, this now is a little bit of PowerShell, right? Well, excuse me, this is pre-PowerShell. This is the code required, this is Visual Basic, and it shows you the code required to create an SMB share, a file share. And you see, well, actually, let's see if we can see this all at once. Where's my mouse? There it is. Can you see it? Can you see it? No. Okay, there, oh, no, sorry. Okay, and if you take a look right there in the middle, that variable is spelled wrong. No, anyway, so, whoa, what the hell's that thing? Okay, but that's how you used to do it in Visual, in VB. Now, with PowerShell that shipped in Windows 7, we had direct support for WMI. So this got a lot easier. So here's what that looked like. You'll see we go and we get a WMI class, the Win32 share, and you set the ACL and the trust, etc. So 20 lines of code. That's still kind of gnarly looking. Well, in PowerShell version 3, Windows 8, this got dramatically simple. This is when we added support for native code to PowerShell. We got fantastic coverage, basically crossed the chasm in terms of coverage. And now with Windows 8, here's how you create a new SMB share, right? New SMB share minus name, my share, minus path, minus full access to this person, read access to that person. So read's nice, right? It's pretty nice. You think, we want to achieve with PowerShell a world where you think, you type, and you get. There's only one problem with this. Well, can I run the script over and over and over again? And the answer is no. It's creating a new share. It's not idempotent, okay? So if you actually want to make this idempotent and deal with error conditions, then you have a script that looks like this. And you see it balloons again. Okay, you got to test to see if it's there. If it's there, you got to check each one of the properties, and you got to clean things out and add them. And it gets really quite large again if you want to write a real idempotent script. Well, with desired state configuration, this is what it looks like. We have a new keyword, configuration. We import the DSC resources that we want to be able to configure against. Remember I mentioned that we support schema. So this is the thing that brings in the schema. And then I say I've got a SMB share, the name, and I just give the properties. And then this then works against everything. Let's see if that's actually true. Let's see if I can do this. Oh, sorry. Yeah, anyway, so there's some of the IntelliSense that you can add. Very nice, very nice. Okay. So that's the evolution of a script. Now, we delivered this in Windows Server 2012 R2, basically the end of last year, I guess last fall. And since then, and we shipped with we chose a minimal viable product approach, right? I think Steve's teased us. He said, you didn't ship a 1.0, you shipped a 0.9 version. And that's pretty fair. But we got great feedback, especially from Steve Morawski. Basically, Steve's we're on his speed dial. The team's knows if Steve calls, stop what you're doing, implement what Steve says, because he's taking the stuff and really using it to deploy, or was using it to deploy Stack Exchange, Stack Overflow, and just had some great feedback. Anyway, so we've been evolving very, very rapidly. We are not waiting for the next version of Windows to ship this, okay? So we reintroduced the resource kit. When we started off in PowerShell version 1, we had what, I guess about 12 resources. Then in December 26th, the day after Christmas, we shipped our first release of the resource kit where we had a bunch more, and then we added more in wave 2 and more in wave 3, wave 4, 5, 6, 7, 8. So you see, this is moving very, very quickly. So within a year, we've had 8 releases of resources. And these are not little fun, there's a variation in things, right? So you have user and package, but over there you see System Center, Virtual Machine Manager, Exchange. So some of these are really quite large. You might have seen some of our Azure announcements where we're saying, oh, we have now in our gallery the ability to deploy multi-machine SharePoint. Any idea how we did that? Desired state configuration using these resources. Now we've also been releasing newer versions of the Windows Management Framework, and in I think a week or so we'll have the latest version of that, where we support classes. We're extending PowerShell with classes support, and largely it's to facilitate writing these DSC resource providers even simpler. The role of standards. PowerShell is very standards-based, and in particular, PowerShell DSC is very standards-based. We use the DMTF management standards, okay? DMTF, the Distributed Management Task Force. MOF is this managed object format. It describes the instances. Again, looks just like JSON. A little different, but just like JSON. WMI is the Windows Management Framework, the Windows Management Instrumentation. Again, it's an implementation of a DMTF SIMOM, standardized agent, and DSC is a agent of that. It's a WMI provider. The protocol for pushing is WSMan, again, the DMTF standard. For the pull protocol, we went differently. We went and used a REST API, and in particular, OData. If you're not familiar with OData, it basically solves the problem of just the sheer randomness of REST APIs, right? REST APIs, my joke is, that's what the designer was doing when he implemented it. You know, they're just random. Blah. And OData basically says, look, we're all going to encounter a similar set of problems. When you encounter those problems, here's a set of conventions for how to deal with those problems. So when you want to identify an instance, use this URI path. When you want to identify a collection of those instances, here's how you do it. If you support sorting, here's how you express that in the URI. If you do filtering, here's how you express it, etc. So it's a set of optional conventions to your REST API, but it's just a standard REST API. One of the great things about OData is the convention that says there ought to be a URI that describes the capabilities of your REST API. What are the methods and what things will those return? And what that does, it allows us to then do all the schema, right? We know the schema of the objects. So great stuff. And you'll see we support that. We have great support for OData. Now, we took WMI, and in the past, you know, in the past there used to be some standards around something called CMIP. Anybody old enough to remember CMIP? Okay, that's sad. Okay, well, anyway, so anybody heard of something called SNMP? Yeah, right, SNMP. SNMP beat out CMIP, okay? There's only 2 problems with SNMP, the S and the N, right? CMIP was actually a good, comprehensive management protocol that did a lot, but it turned out it was difficult to implement. So Marshall Rose and a couple guys said, hey, let's just ignore all that tough stuff and do SNMP, something really simple. And indeed, it was very simple to implement, and boy, did it just take us nowhere. Okay, yeah, it's used a lot, but it really doesn't solve many of the management problems we really need. It turned out CMIP would have been much better if we had standardized on that. So why didn't we? And the answer was, there was no such thing as open source back then. I think if there had been an open source movement and there was an open source implementation of CMIP that people could just pick up and then focus in on the things that they want to use it for, we would have had a very different history of computing over the last 20 to 30 years. Okay? So same thing with WMI. There are the DMTF standards. It's actually a very rich object model, but the implementations out there honestly have been lacking. So we had picked up one, we participated in one, Open Pegasus. It's very big, very slow, very cumbersome, very difficult to use. And we said, back when this was sort of a side project, maybe I'll manage some Linux stuff here and there, whatever, that was fine. But at some point we said, no, we are a software company. Microsoft, I don't know if you know this, right? Microsoft is a software company, not a Windows software company, right? That's a fundamental transformation. And so this has been coming on for a number of years. One of the early things was our management stuff, where we made a commitment to say, hey, we want to manage all the elements that you have, not just the Windows elements. So when we made that decision, we looked at Open Pegasus and we said, yeah, that ain't going to do it for us. We need something that is fast, lightweight. In fact, it's faster and lighter weight than WMI. We implemented this OMI. It's an open implementation of those standards. It's open sourced. It's running on, I think, 40 some odd implementations of variations of Unix. And we have that running in Cisco, Arista, and how do you pronounce it? Yes, that's it. Wow. They're switches. And in fact, Dell switches now too. So this has been going great. Very, very, very fast implementation of this. Now any platform that can manage desired state, you can manage Windows or Linux from any platform that supports these standards. So this is in no way coupled to any Windows runtime, etc. Now, we have an authoring mode in PowerShell, which is enhanced, but you don't have to have that. You can just produce the documents, use the protocols, and manage us directly. And again, the key there is without adding any additional agents. Anybody in the management business, or you guys know, one of the biggest headaches in management is getting an agent on the box. You get the agent on the box, it consumes too many resources, then something goes wrong with the box, somebody restores the box, they forget to put the management agent in, so, then you put the management agent in, then you got to set up the trust again, mess. That doesn't shorten anything out. If I start to shake and stop talking, someone do something about that. Okay, so that sort of explains things, but then there's a question, well, okay, but why are you doing desired state configuration on Unix? This is a little bit strange thing. Well, I mentioned to you, Microsoft is a software company. The thing I like to tell people to help them get their head around this notion, because they hear that and they're like, give us that strange look, like, really? I said, look, in the context of Azure, we make more money if you run 10 instances of Linux than if you run 2 instances of Windows. Okay? So in the context of Azure, it's just a volume business. We want you to use as much volume as you want, as many resources, whatever those resources are, we want to help you be successful. So we're very much of a software company. So here, in the context of the Cloud OS, we have two things we're trying to achieve. First is the heterogeneous fabric management. So in a data center, switches don't run Windows, right? So we got to be able to manage them. Storage devices, controllers, etc. We need to manage all those elements. So too, in the heterogeneous client space, we want to have a single management stack for you to be able to consume as many resources as you want. To say, well, okay, that's great, but here's how I manage Windows, and here's how I manage Linux, and they don't quite work, and they're different. That is an impediment to you consuming your natural level of computing. We want to minimize the friction for you to consume your maximum level of computing. So that's why we're doing this. The other thing we're trying to achieve here is something I call data center plug and play. So anybody ever try and connect a CD-ROM to a machine prior to plug and play? Anyone? Okay. So you remember those paper clips that you'd unfold and the dip switches and the tiers and you were convinced you were the stupidest person in the world? Oh my God, that was it took me 2 days to get that thing running. It was the worst thing. And then when my friends came and said, oh, I hear you got a CD-ROM on your machine, it's like, yeah, you don't want to do that. Just don't do that. No. And now it's easy. It's easy because of plug and play. So my boss, the other, I forget when this was, but not too long ago, somehow he got something, it was on a DVD, and he looks at his Ultrabook and he's like, yeah, I never thought about it before. I don't know what I'm going to do with this thing. And so we went to a store. I like to joke it was a 7-Eleven, but I mean, it's just some random store, pulled a DVD player, USB DVD player off the rack, opened it up, plugged it in. The machine discovered it, found out what it was. He put it in his DVD. He got the information out. He unplugged it, put it in a drawer, and hasn't opened it since. Now, why was that possible? And the answer is because of standards, right? So we, Microsoft, worked with the industry, did a lot of hard work to be able to go develop a set of standards so that when hardware is introduced into the environment, we can detect that. We can ask it what it is, find that out, find the appropriate software to bring to play, and then just offer that device's services to the user. Okay? That is not at all the question. That is not all the case today with data centers. Data centers are very, very hard. So what we're trying to do is we're trying to create a set of standards to make it easy to bring plug and play to data center devices. And really in the Unix world, if you take a look at the configuration management space, the vendors just seem to be involved in a big food fight with each other, and there seems to be no effort to try and say, hey, let's standardize on a platform so that if a Unix resource provider can write one thing and have it work with all the products. Today you say, well, these resources, this guy has these many resources and that guy has those many resources, and are they the same quality, et cetera? Heaven knows. Anyway, so they're not taking a platform approach, and we are. 2 weeks ago, we showed desired state configuration running natively inside a Dell switch. Pretty impressive stuff. And so here's a set of schema that we're standardizing to do that data center plug and play. So with Dell switches, you're going to be able to discover them, be able to configure them using desired state configuration the same way we can manage a Linux instance or a Unix box, a Windows box. So let's go back to the agenda. I wanted to explain to you why we were doing desired state configuration. And the answer is we had to do this because Windows is an API-oriented operating system, and existing configuration management tools just do not work on Windows. The next, what is desired state configuration? It's a tool-agnostic, standards-based, distributed configuration management platform. And why are we doing DSC on Unix? And that's to provide a single common management stack to manage every element of your data center. It's that simple. So we have a little bit of time for questions or comments. If you think that's all nonsense, feel free to say so. If you could use the mic, that'd be great.
Hi. Are you targeting this entirely at the data center at the moment, or are you thinking about pushing this down to managing things like small servers or even desktop clients? Or
small servers, absolutely yes. Desktop clients, I will say this. I think right now I'd say my primary focus is on server and data center scenarios. Some people have pointed out you can use this technology for clients as well. I'd say I think the client space is undergoing a kind of a struggle for the soul of the client. My personal belief is that in the end, we're going to decide that there are really only two types of devices, right? There are simple kind of consumer-oriented devices, like phones, where you say, I might have a dozen or so things that I configure. And then you're going to have rich sort of server-type devices. And I'd say in the client right now, it's sort of a tweener. It can't decide which one it wants to be. So my view is that they're going to be, when you have 100,000 of them, you probably want to treat them more like consumer devices where you have a very small number of controls. Now in the server space, let me be clear about this. In the server space, you're going to want to have fine control. You're going to want to have a lot of switches, but you're not going to use them. You're going to standardize. All your servers are going to look the same. But you might say, well, but for my application, I get so much more benefit if it's configured this way. So between different customers, you want to have lots of variation to support exactly what they need. But then for any particular customer, they're going to say, all my servers look like this. So that's why it seems like a paradox that this has a lot of control, but you want it to be very simple.
Okay, thank you.
Mine is actually a follow-up of his, actually, believe it or not. In my experience, PowerShell is being used in places you probably don't expect. And in fact, where I'm using PowerShell is actually on laptops. I use PowerShell to set up my configuration so I can automate each individual's configuration with like Chocolator or Nutmeg. It's a great end user configuration tool. It really, truly is. Now, the hardest thing is getting my wife to use it. Now, this is where I think some improvement could happen. Like, it's designed as an object-oriented design. Now, it's kind of hard to get a non-IT person to understand object-orients, but it's actually easier to get her to understand functional. So I can get her to work with functional expressions fairly easily. So my challenge has always been how to re-express things in a functional nature versus an object nature. So I can use it on the end user, like her laptop, and get her to automatically install tools using Chocolator versus going to this link, click, 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 click.
Yeah. So don't go far. I'm going to ask you a question. So let me clarify my previous comment. PowerShell is definitely use it for everything, right? Automation, you want automation everywhere. Then there's a question about desired state configuration. And there's a distributed infrastructure component. The infrastructure required to support the semantics of a data center are very different than this infrastructure you'd build to support very large collections of clients. We know this because we're the team that does group policy. Group policy does that pretty reasonably well, and it's got lots of things to deal with that problem. What I'm saying is for the infrastructure of desired state configuration, I'm currently focused in on servers. Now, to your point, does the PowerShell verb noun help? I mean, that was sort of what we wanted to intend, was that people could just think about what they want. Get processes, where handles greater than 500, sort by handles, format the name and the handles and the company name. Does that help, or?
For me, I can handle it because I can I reset my mind accordingly, but it actually is a reset for me. Now, it's yes and no. It's not really the answer. The problem is it is really still an object-oriented expression language. Okay, and that is harder for me to express to my wife. Okay, you want to do this function with it, so you're going to create this object. Well, I don't really want to create an object. I want to do a function.
Yeah.
Okay, so I have to re-explain to basically how to make an object do a function. So the noun verb conceptually does help you memorize things. It's because I have a Linux and Unix background. I've always going to memorize. I have memorized the Unix system. Like it took a while, but I memorized it. So it will take time to memorize the different expressions on. So it is still memory process.
Yep.
You can't get around that with noun verbs.
Yeah,
unfortunately.
I had a very similar reaction when I went to work for Digital and was required to use VMS DCL. And again, I came from a Unix background. So then I'm required to use this VMS DCL. And oh my Lord, the words I just swore a blue streak for weeks. Frickin' crap, rah, rah, and it's like, rah, doesn't have pipelines, or crappy pipelines, rah, 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 what's this, just horrible syntax. And I was just beside myself. I hated it. And at some point it's like, okay, well, what are you gonna do? Like, that's the job. So, like leave or just take a deep breath, put your big boy pants on and learn it. And so I thought, okay, well, I'll learn it. And after a few hours, when I just stopped fighting it, I learned it. And then after a few days, I'm like, wow, this thing's awesome. And it had some wonderful characteristics. I mean, the degree of consistency that it provided, within a week, I just loved it. In fact, as I mentioned, we stole a lot from when we designed PowerShell, we took our inspiration from Shell, took some of our syntax elements from Perl, but the command line syntax we get from VMS DCL. The verb noun structure, the fact that you have long self-documenting parameters that you only have to specify enough to disambiguate, the minus confirm, minus what if, minus verbose, things like that came from VMS DCL because it was wonderful. And in fact, it got us to the world where we said, the joke was if somebody put a fish finder on your VAX, hey, Jeffrey, somebody put a fish finder in the VAX. Do you know what to do? And you say, sure, get/fish finder, show fish finder, log fish finder. You made a set of predictions, and by and large, they were right. It taught you how to think about it. Whereas, like for instance, okay, I'm going to throw a rock at the Unix guys. What does -L do? Who the frick knows, right? Well, it depends. Depends upon the command. It depends on the instance of the OS. And anyway, so both environments have their strength, and we tried to combine them. And my real point was, yep, some of these things you just got to get your head into it, and then when you're in, you're like, oh yeah, actually it's pretty straightforward.
Okay, so I'm actually sorry.
Well, I'll be around, so you can ask questions, and thanks so much for your time. Appreciate it.